Michigan State University is racing into the future by participating in the Indy Autonomous Challenge, which officially launched in 2019 and brings together academic institutions and public-private partnerships to challenge university students from across the globe to invent and test a new generation of automated vehicle software to operate fully autonomous race cars.
Yeah, so I'm Daniel Morris. I'm an associate professor in the Biosystems and Ag Engineering Department, as well as the Electrical Computer Engineering Department. And I'm really excited about 3D sensing and automation. So I have a background in robotics. I did my PhD in robotics. And since then, I've been working on lots of areas of research and development that involve incorporating sensor data into usually a robotic platform, could be stationary or mobile, and then ways of processing that involving artificial intelligence or machine learning, and turning that into an understanding of the world to do interesting things. And there's lots of interesting things. So autonomous vehicles is one area that is really exciting where that applies. Autonomous agriculture is another one, and I kind of want to span both of those areas.
And Judd, tell us a little bit about your almost a year, I think, into being mobility director. How is it going?
It's going great, Russ, and thanks for having me on the show again. It's been an exciting first year in the new role as mobility director for Michigan State University. I have thoroughly enjoyed the opportunity getting to work with faculty members like Professor Morris on the cutting edge of advanced mobility technologies. And the Indy Autonomous Challenge team that we have started up here at MSU is one of the most exciting opportunities that we've had since I've started. And I'm thrilled to be talking with you about it today. So the Indy Autonomous Challenge was started about 5 years ago with some support from the state of Indiana. They were looking for what's the niche for their state in the future of mobility, and of course Indy racing came front of mind. It at the time I think seemed a bit like a pipe dream to be racing autonomous Indy cars, but here we are several years later, and Michigan State University is the first and only university from the state of Michigan participating in the IAC. And we race against 15 other university teams from across the globe in a series of races at tracks across the globe. And it's very exciting to see Professor Morris and his team and what they're able to do in developing these technologies that actually make the race car go.
So, Daniel, all of this really fits into the interest you were just telling us about. Give us your thoughts on this challenge and what's cool about it.
Racing is a sport of speed and fast reaction, as well as a sport of strategy, figuring out how to drive a car to beat your opponents and pass, avoid collisions, and yet still make it to the lead. And so it involves perception, being able to understand the world around the car, figure out where all the other cars are going. Involves planning a trajectory that's going to take your vehicle the fastest it can through the course and around the other vehicles. Also, obstacle avoidance. I mean, there's another car passing you. You have to avoid a collision and plan a path that optimizes your speed given all these other constraints.
Well, and how would you compare and contrast what the driver does in the car to maybe what the engineers are doing driving the autonomous vehicle? They're making the similar decisions, right?
Yes, they're making the similar decisions. And it's similar to, if we think of what's autonomous vehicles, like probably a lot of you have heard about Waymo taxis, autonomous taxis that are driving around the city. And in that case, their objective is safety, maintaining safety of the passengers and following the rules of the road. So here we've got an autonomous vehicle, but we have to go much faster. We can't go at highway speeds. We're going 100, hopefully 150 more miles per hour. And we've got an array of sensors that the human, we have our eyes, our ears, and we can feel. So we have also an array of sensors, but the car's got a lot more. We've got LiDAR sensors, radar sensors, and cameras that can see all around the vehicle all the time. So in that sense, autonomous vehicle has an advantage over what a human can do. Human, we actually can only focus on one thing at a time, whereas an autonomous platform, it could be focusing on all the different vehicles surrounding it, planning a path that could optimize all of them. So there are potential for autonomous vehicles actually to be much better than human drivers, if we can get there. But of course, that's a difficult problem, being able to take all that information in and do something sensible or optimal with it. That's the big challenge that we're faced with.
It's important to understand the one of the key aspects of the Indy Autonomous Challenge is that all this hardware is standardized across all the teams. The vehicle, the engines, the sensing equipment, and even the computers that we're using are equal amongst all of the teams. What we're really being challenged on is the ability of the faculty and the students involved to program the computer to think, as Daniel pointed out, in the most optimal way possible, to compute that information quickly and make decisions that are appropriate to win the race. That's really what the challenge is focused on. That's who our driver is this software that we've been developing. And once it's out there on the racetrack, it's kind of a hands-off. The software is developed, the car is programmed to make its own decisions, and then once it's out on the racetrack, we're not allowed to tell it what to do. This is not a drive-by-wire sort of scenario. The cars are out there thinking independently using the software that's been pre-programmed with.
Wow, I didn't realize that. I figured you were sort of driving it, but that wouldn't be autonomous then, would it?
No. Yes, fully autonomous. Once it goes onto the racetrack, we can't do anything. We just have to watch and bite our teeth and hope that nothing bad happens. And you can see cases where if you hadn't thought about a certain scenario, the car might do something kind of dumb. Actually, there was the Formula race in Abu Dhabi. They had a recent race there. This is not IndyCar racing; it's Formula racing, but they're also doing autonomous racing. And there, some of the cars stopped for the lead vehicle, which had gotten off the race course, and they didn't realize that they should be able to pass it. So they were like stuck in the middle of the race course because the teams hadn't thought about that situation ahead of time. So that's a concern. How do we think of all the possibility scenarios that the car couldn't encounter and ensure that it operates correctly in all those cases?
And is really the ultimate goal of participating in something like this, Judd, informing the larger mobility work here at MSU and just learning more about making autonomous vehicles viable?
It is. There's a variety of reasons why MSU found our participation in the Indy Autonomous Challenge to be an attractive opportunity. Number one is because it's a research platform that we're able to develop autonomous vehicle technologies, sensing equipment technologies, sensor fusion technologies, and decision-making processes. We have a professor who works on applying game theory techniques to the decision-making process of an autonomous vehicle. The connected vehicle aspect of the car as well, because it's got to communicate using its sensing equipment with the infrastructure on the tracks that it's driving around. There's no better scenario for us to be developing these technologies than on a racetrack with a vehicle going several hundred miles per hour. It is the most extreme scenario that you can ask a vehicle to perform under. In fact, that was one of the main reasons why motorsports was invented in the first place, was to help innovate the next generation of mobility technologies. And that's what we're continuing to do here with autonomous technologies as well. In addition to the research application, this is also an incredible experiential learning opportunity for our students. they are able to, through participation on our Polymove MSU team, take the knowledge that they've learned in the classroom and apply it in a real-world setting. And as I mentioned, not just any real-world setting, but one of the most extreme possible scenarios that one can imagine. But it also gives them a chance to participate in a team and graduate out of the MSU program with practical application skills and a team attitude that I think gives them an incredible leg up when it comes to employment opportunities post-graduation. There's a third reason why this challenge has been such an opportunity for MSU and MSU Mobility, and that's because of the opportunity to further our network opportunities with industry partners. There is obviously a lot of potential for commercial applications of the technologies that we're developing, and we're seeing a lot of industry partners, government partners being interested in working with us to develop these new innovations in autonomous vehicle tech.
The autonomous racing, the way I see it, is we break down the big problem. There's so much there for an autonomous car, and so we subdivide it into smaller tasks. So there's a localization task, how to localize the vehicle and get its orientation and its motion. We could call that the ego vehicle. And then that becomes a sort of a research area for some students or a project area for others. And what happens when GPS drops out, for instance? And that's actually a significant problem that we need to deal with. And it's pretty challenging because even small errors, 10, 20 centimeter error, can lead to errors in our controller. Our controller uses very precise localization. So the localization, there's the target tracking. We need to precisely track other vehicles around us. So that's a problem that some students are working on. Another is planning. How do we plan a trajectory to beat our opponents? And there's lots of strategies that real racers use, but how do we turn that into a strategy for an autonomous vehicle? I think that's pretty wide open, and there's a lot of interesting work there. So students are really excited about this, and we'll be going to a race in September in Indianapolis, and we hope to have a number of students come to that race with us.
We have the race coming up in September at the Indianapolis Motor Speedway. We actually have a race in July at the Goodwood Festival of Speed in Sussex, England. We had our first race, actually, this past January at the CES event in Las Vegas. The race took place at the Las Vegas Motor Speedway, and that was the first race that MSU got to participate in. It was an incredible experience seeing firsthand these vehicles traveling 150, 160 miles per hour autonomously. If you've never seen an autonomous vehicle, I would say that this one will certainly light up your imagination. And it did that for me after the sun went down. Because we don't need human eyes to operate the vehicle, the track lights were turned off and it was pitch dark. And there was a really fun, really interesting scenario that took place where we put ribbon lighting on all of the cars and raced them in the dark. And it was such a cool moment. For me, it reminded me, if you recall the movie Tron, it looked exactly like this. The vehicles just whipping around the track with these LED lights on them, and all you could see was the blur of fluorescent green making its way across the track in front of you. And it was just such a cool moment. And this, to me, opens so many doors for what the future of motorsports can be, because of the fact that we are operating the vehicles autonomously.
So right now we break it up into human-driven and fully autonomous. But there's a whole spectrum, actually, of possibilities for vehicle driving in between that. So we can have augmenting human capabilities. So the technologies we're developing for fully autonomous vehicles could go into a vehicle where the human's driving but isn't paying attention, and the autonomous system can take over and drive. Or it could provide superhuman capability of avoiding a collision. What right now we have quite a long delay between being able to react to an oncoming vehicle, whereas an autonomous system could be able to react much more quickly. And that could be either fully autonomous or just the safety system on your own vehicle. So that's what I would really like to see in my car, a reaction system that prevents me colliding into something or or automatically avoids an oncoming car by swerving aside. So that's an application that's pretty exciting for me.
And what happens if like the internet or GPS goes down during a race?
That's a good question, because we're using internet to monitor it. We're not actually controlling it over the internet. I'm not really sure if the internet going down would mean we'd have to stop purely from a safety perspective because we're monitoring it. From a practical perspective, we should be able to still race without the internet. If GPS fails, we're developing technologies to go without GPS. We're not fully there yet, but right now we're working on, if GPS fails for a short time, we can keep going. And I think we have plans for being fully autonomous with no GPS, but that's a little ways in the future.
Well, I would be remiss if I didn't bring up two important facts. The one is that the team MSU is now a part of, the Polymove MSU team, holds the current Guinness Book of Records land speed achievement for an autonomous vehicle. We have the fastest autonomous vehicle on the planet. It goes 192.2 miles per hour at its top speed, or at least that's what we've been able to do so far. We're hoping to be able to beat that in the near future. The second is we are investing in this team. Obviously, the vehicle and the computer systems and the sensing equipment didn't come free of charge. And being able to sponsor the students and get everybody to and from races and make necessary repairs to the vehicle should it need them in order to keep it operational all comes at a cost to the university. And so for any industry partners or individuals who are interested, please reach out and contact us. We are actively looking for support and sponsors to be able to join our team and help bring this experiential learning opportunity to more students and keep the MSU team ranking number 1 in the Indy Autonomous Challenge leaderboard.
And you can reach out to Judd through mobility.msu.edu as well. Judd, I'm wondering too, does this inform where we're going? I sort of asked you before in the whole autonomous space anyway. Where do you see it all going?
I think we're a long ways away from seeing fully autonomous vehicles going 150 miles an hour down I-75. But again, there's definitely a practical application for some of these technologies that we're developing. Definitely some commercial opportunities for the technologies that we're developing. And more importantly, the students that have the experience working on this car and working with Professor Morris and his team are coming out of the MSU ecosystem and going into the mobility sector. And they are going to be the ones that are developing the next autonomous vehicle products for Ford and General Motors and some of the cars that you and I do own and will operate in the future. And it's going to be incredible to see the types of innovations that they're going to be capable of thinking to put into those cars because of their experience working on the Indy Autonomous Challenge team here at MSU.
Yeah, we're working with the team at Politecnico di Milano, and they have a fantastic group of engineers and students that have been developing this vehicle for a number of years, and we've joined in with them. We've had a great experience working with them. They're coming to the races, and we're seeking to build our software to integrate with their software and jointly build a faster, better vehicle.
I also want to give a shout out to another partner without whom we would not be able to do this, and that's the State of Michigan's Office of Future Mobility and Electrification and our Chief Mobility Officer, Justine Johnson. Their generous support has helped get the Polymove MSU team up off the ground and involved in some of these initial races. They have been just absolutely wonderful about working with us, and we really appreciate their support.
One of the reasons we can work together across the globe with partners is a lot of the development uses simulation. So we have a number of different simulation platforms. Actually, a company called DSpace is making a sophisticated 3D simulator that we're starting to plug in. We can also use data collected on the races and replay it using software called ROS, Robot Operating System. And so our students can do a lot of their development with data on the cloud or on our computer system and test it out in our lab without any hardware involved.
The Indy Autonomous Challenge is a unique research platform, an incredible experiential learning opportunity for our students, and a great way for MSU Mobility to expand its partnerships within industry to help develop the future of automated and connected vehicle technologies and really do it in one of the most cool and extreme, fascinating ways. There's nothing like high-speed, competitive motorsports that brings out the best in innovation.
I think autonomous racing is really exciting as we're right at the boundary of technology. We're developing new technologies that haven't been seen before and are likely to have significant impact in the future of mobility affecting all of us. So I think students are really excited about that. Faculty are excited, and together we're working on this problem, and we're going to see real outcome in the races that we participate in, but longer term in the cars that we drive.
For more, visit IndyAutonomousChallenge.com. I'm Russ White for MSU Today.